So guys, today we are going to deal with one of the most interesting topic, saying that what happens if you are going to dissolve a solid in a liquid and the gas in a liquid. So first and the foremost thing, we'll be saying the solubility of solid in liquid. Of course, by the fact we come to know that whatever the solute you are adding will be in the solid state, and whatever the solvent you are going to take, that will be in a liquid state. One most important thing you have to remember, guys, that each and every solute does not dissolve in each and every liquid. For example, if I say, if you are taking the sugar as a solid, of course, it is going to get dissolved in your water. But the same sugar is not able to dissolve in benzene. Similarly, when you are taking that of your naphthalene balls, of course you'll be knowing what do you mean by naphthalene balls. So this is getting dissolved in benzene, but the same does not dissolve easily in water. So that is the reason I said initially that each and every solute does not dissolve in each and every solvent. So we just give one of the most commonly used words in order to keep this thing in our mind, that like dissolves in like. Like dissolves in like. You can ask me, so what does this like refers to? Remember guys, polar solute dissolves in polar solvent. For example, if you are taking your NaCl, which is your polar solute, it is going to dissolve in a polar solvent, that is your water. Polar means nothing which will be having a positive and a negative charge. A polarity is existing between them. There is somewhat a partial charge difference existing within a solute and also within a solvent. Similarly, non-polar solute dissolves in a non-polar solvent. The greatest example is here, naphthalene, which is getting dissolved in a benzene. This is your non-polar solute, this is your non-polar solvent. Hence, in order to understand these two things, you are giving a general term or general sentence saying that like dissolves in like. So now the question arises that what happens when you are going to dissolve your solid in a liquid? Basically, we know that two processes takes place. For example, when you are dissolving your NaCl in water, we are seeing that your salt molecules are getting dissolved. This is the one process which is called as dissolution. Dissolution, that is whatever the solute you are adding to the solvent, it is getting dissolved. The process is called as dissolution. But there is another process which we have seen, which is called as crystallization. Crystallization. That is what is happening means, if the concentration of the solute, if you go on, increases, the solute solid particles will collide with each other and comes out as a solid which will be in a purest form called as that of your crystals. The process is called as that of your crystallization. So whenever you are dissolving a solid in a liquid, there are two important processes taking in a system. One is called as a dissolution, where your solute is getting dissolved. Another is what your solute is going to collide with each other and will be extracted out as a crystal, called as that of your crystallization. So there is a system of a dynamic equilibrium which will be existing, both that of your rate of crystallization will be equals to rate of that of your dissolution process. Hence the system is called as to be in a dynamic equilibrium. Most important thing, of course, here we have to know that what do you mean by original solution, or you can also say original solution as that of your saturated solution. Very much important when you're dealing under this heading. Of course, saturated solution means nothing. That is the capacity of the solvent where it will not be having the efficiency to get dissolved more of the solute. That is, for example, if you are preparing a lemonade, take a glass of water which has been added with some lemon and go on add the sugar to it. Of course, when you're stirring it, you could see that the sugars are getting dissolving, but at a particular concentration, the sugar gets remained at that of the bottom, at that temperature and the pressure to that particular solvent. So that residue will not be further get dissolved. So such a solution is called as what? Saturated solution. So if you're remembering it, we have done it in our first PUC class while preparing the original solution. The same thing. So in a solubility of a solid in liquid, we have to make sure that like dissolves in like. So whenever a solid is dissolving in a liquid, two processes are in dynamic equilibrium. That is a dissolution and a crystallization. So what happens if you go on add the solute to a solvent at a particular concentration, your solute remains at the bottom as a residue, where the solution is said to be a concentrated solution and the solution has become saturated at same temperature and the pressure. Now we have to see that what will be the effect of temperature on this solubility of a solid in a liquid. Basically guys, you have to remember one important thing, the Le Chatelier principles. Of course, whenever a system is in an equilibrium, this principle plays its vital role. So what is it says? If it is saying that if your system, that is whatever you are dissolving, the salt or the solute, if it is an endothermic reaction, that is whenever you are adding a solute to a solvent, temperature is getting absorbed. Such a reaction will be called as that of your endothermic. For example, when you are adding a sodium chloride salts to a test tube, I have said you many times to just touch the test tube. We are feeling the coldness at the outer walls of the test tube. So such a process is called as an endothermic. So whenever such endothermic reaction is being carried out, so at this reaction, if I am going to increase the temperature, what happens to the solubility is my question. So the reaction means what? You are dissolving a solute in a solvent and the reaction is endothermic. In that reaction, I am going to increase the temperature. What happens to the solubility? Of course, whatever the increase in temperature you will be doing, since it's an endothermic reaction, it will try to decrease the temperature. So when it tries to decrease the temperature, what happens to the solubility on the other hand? Solubility increases. So if a reaction is an endothermic, and in that reaction, if you're going to increase the temperature, the solubility goes on increases. But if the system, that is for your exothermic reaction, that is if I'm going to dissolve my NaOH in water, what happens is an exothermic reaction. In that case, now since the temperature is also rising, along with that I am also increasing the temperature from the external source. What happens to the solubility? Can you guess? Yes, the solubility goes on decreases. So we have to, since effect of the temperature follows a Le Chatelier principle, whatever the dissolution process you are doing, if it is an endothermic reaction, on increasing the temperature, remember, solubility goes on increases. If your dissolution process is an exothermic reaction, in such a reaction, you're increasing the temperature. Of course, what happens? Solubility decreases. If I come with respect to the another quantity or a parameter, that is of your effect of the pressure, please do remember that in the solubility of a solid in a liquid, both the mediums are incompressible. They are not highly incompressible. That is the reason what happens. Pressure has no effect on the solubility of the solid in liquid.